This is new nature, and we spent weeks pulling together the latest research from glaciologists, geophysicists, and ice core scientists. Antarctica is far more interesting and far more valuable than it looks from above. To see what nations are really chasing, we have to go under the ice. But first, let's zoom out. Antarctica is the 5th largest continent on Earth, larger than the United States and Mexico combined. It holds 70% of the planet's fresh water, locked inside an ice sheet that is thick enough to bury the Alps. It's the coldest, driest, and windiest place on the planet. Temperatures drop to minus 90 degrees Celsius. Winds can exceed 200 miles per hour. In winter, parts of the continent don't see the sun for months at a time. And yet, life exists here, from the surface to the ocean, and deep beneath the ice. So let's go down. Antarctica is a library. An ice library. Snow falls in Antarctica year after year and compacts under its own weight. Each layer is a year, like tree rings. As the snow compresses, air gets trapped between the grains. Tiny bubbles of atmosphere sealed in time. These rods are ice cores. Scientists drill down and pull up long cylinders of frozen history. Trapped inside are tiny bubbles of ancient air. The deeper the core, the further back in time. This is one of the oldest continuous ice cores ever recovered. Drilled from nearly 3 kilometers down, it contains air that's about 1.2 million years old. If it warms, that record is lost forever. This is how we know what Earth's atmosphere was like long before modern humans existed. The ice preserves carbon dioxide levels, methane, volcanic ash, and temperature signals. A complete atmospheric archive. It records when the Sahara was green and when mammoths walked the Earth, when carbon dioxide levels were half of what they are today. The ice doesn't forget. But this is still just the top layer. Before we go deeper, look at what happens to snow once it hits the surface. Most of Antarctica is covered in bright, reflective snow. But in some places, powerful winds strip that snow away, exposing something unexpected. Fields of blue ice. This ice began as ordinary snowfall, compressed until air bubbles were forced out. With no fresh snow on top, light penetrates deeper and the ice absorbs reds and yellows, leaving it glowing blue. In some regions, blue ice reveals ice that's hundreds of thousands of years old. Elsewhere on the surface, the opposite happens. Snow keeps falling. Year after year, it piles up, compresses, and buries whatever lies beneath it. And then there's this. Mount Erebus, the most southern active volcano. Hot volcanic gases escape from vents on its slopes, and where those gases meet the ice, they carve warm caves. Inside those caves, scientists have found mosses, algae, and DNA sequences that don't match anything we've seen before. Life finding a way in the least likely place. And as we go deeper into the ice, you'll start to realize Antarctica is much more than just ice and snow. It also has heat, history, and it's hiding things we're not supposed to find. We're about 1,000 feet down now, and this is where Antarctica stops behaving the way people expect. Most people think of Antarctica as one giant block of melting ice. In reality, it's doing two different things at once. In West Antarctica, ice is thinning fast. Glaciers are accelerating toward the ocean. Ice shelves are breaking apart. Some of the fastest ice loss on Earth is happening here. But East Antarctica tells a different story. It's colder, thicker, and in some regions, snowfall has actually added ice, at least for now. Satellite measurements show that despite these gains in the east, Antarctica, as a whole, has been losing ice for decades. But the continent isn't responding as one system. That's the paradox. And it's why this layer matters. If we don't understand what's happening here, in this compressed transition zone inside the ice, we can't understand what comes next. So, we keep going down. You're more than a kilometer down now. The pressure here is extreme. Between the ice and the bedrock below, water is moving. Beneath Antarctica, thousands of rivers and lakes from a connected drainage system. Some of these subglacial lakes hold volumes of water comparable to major U.S. reservoirs. When they drain, it happens fast. In some events, billions of liters of water are released over just a few days, comparable to a large fraction of a lake, like Lake Mead moving underground, unseen beneath the ice. That water can travel hundreds of kilometers across the continent. As it redistributes below, the ice above responds. The surface lifts and settles by meters as pressure shifts underneath, like weight moving across a frozen shell. We've barely touched this world directly. If you add up every place humans have physically reached beneath the ice, it covers about the size of a basketball court. So instead of digging, we fly. Helicopters sweep low over the ice carrying massive electromagnetic sensors, huge loops suspended beneath them. Systems like SkyTem send signals down through ice and rock, revealing what's frozen, what's liquid, and what's moving below. We're echolocating a hidden continent. And occasionally, this hidden system reaches the surface. This deep red stain spills from Taylor Glacier. It's streaking the ice like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, no one could explain it. Algae was suspected, but algae needs sunlight, and this water comes from deep inside the ice. Look closely, and you'll see the water comes out clear. This is ancient, briny water, more than twice as salty as the ocean, which keeps its liquid even at -5 degrees Celsius. It's been sealed beneath roughly 400 meters of ice for millions of years. Dissolved iron reacts with oxygen, oxidizing on contact and staining the ice red. Blood falls gives us a glimpse into what these hidden rivers transport beneath Antarctica: iron, organic carbon, and nutrients. There are thousands of subglacial outflows like this across Antarctica. Antarctica's ice feeds the ocean. The ocean feeds the whales. Now, let's go back under the ice. You're more than 3.5 kilometers down now. The pressure is crushing. The darkness is absolute. And beneath the ice lies one of the largest lakes on Earth, Lake Vostok. It is 240 kilometers long and 50 kilometers wide and completely sealed beneath the ice for millions of years. It has never seen sunlight. It's been isolated from Earth's atmosphere longer than humans have existed. a potential habitat for microbial life unlike anything studied before. Lake Vostok isn't unique. There are nearly 700 subglacial lakes scattered across Antarctica. In the few scientists have sampled, they've already found evidence of life. In Lake Whillans, microbes survive by extracting chemical energy from rock. In Lake Mercer, researchers found microbial signatures preserved in the sediments. And remember the amphipods from the beginning? They were found beneath the Cam ice stream, hundreds of kilometers from sunlight, swimming in total darkness. That makes Antarctica one of the closest natural analogs we have to icy worlds like Europa and Enceladus. Moons with oceans sealed beneath frozen shells. If life can exist under kilometers of ice beneath Antarctica, it widens the range of conditions we have to consider elsewhere in the solar system. Antarctica isn't hiding aliens, but it's showing us what alien life might look like. And the deeper you go, the more heat you find. You're nearing the bedrock now, and it's not the solid, frozen foundation most people imagine. Beneath West Antarctica are dozens of volcanoes hidden under kilometers of ice. Some of them are active. They don't erupt upward. The weight of the ice suppresses explosive blasts. Instead, heat builds below, melting the ice from underneath and carving chambers of water and steam. The heat destabilizes glaciers and accelerates ice loss. Scientists have found ash layers trapped in ice cores, evidence of eruptions that happened while the ice was forming. More recent seismic data suggests some of these volcanoes are active today. This geothermal heat wasn't fully accounted for in early ice models. It helps explain why parts of West Antarctica are changing faster than expected. The ice isn't only responding to warming from above, it's being heated from below. But these volcanoes are only part of the story. They sit on the surface of something much larger. A continent buried beneath kilometers of ice. This is the bedrock. The actual continent, buried beneath everything you've descended through. Using data from millions of measurements, scientists can digitally strip away the ice. This is Bed Map 2. When the ice disappears, the surface you thought you knew vanishes with it. What's left is a vast, rugged landscape. Mountain ranges comparable to the European Alps lie completely buried beneath the ice. The Gambortsev Mountains stretch across the interior, their peaks rising thousands of meters, unseen for millions of years. Denman Canyon cuts through the bedrock nearby, the deepest land canyon on Earth, plunging more than 3.5 kilometers below sea level. Ancient river valleys run between them, preserved exactly as they were tens of millions of years ago. BedMap also reveals something more fundamental. Antarctica isn't one continent underneath. It's two very different geological worlds. East Antarctica is ancient, thick, and stable, part of one of the oldest pieces of continental crust on Earth. West Antarctica formed differently. Over tens of millions of years, tectonic forces stretched the crust apart. It thinned, fractured, and sank, creating deep basins long before ice ever arrived. That thinning brought heat closer to the surface, helping explain why West Antarctica hosts dozens of volcanoes beneath the ice. When Antarctica drifted south and ice began to accumulate, those low, fractured regions filled first. Strip away the ice today, and much of West Antarctica sits below sea level. The continent breaks apart into islands and highlands. Fossilized pollen and root systems preserved in the rock show us this was once a green forested land, with rivers and temperate climates, when Antarctica was part of Gondwana. And then there's the Wilkes land gravity anomaly, a circular structure 300 kilometers wide buried beneath East Antarctica. Its origin is still debated. It may be one of the largest impact scars on Earth, or something else entirely. Whatever it is, it's massive and it's hidden. For millions of years, the weight of the ice has pressed Antarctica downward, pushing the crust into the mantle below. When ice is removed, the land doesn't just sit there. Over centuries to millennia, it slowly rises back up, changing coastlines, altering drainage, and reshaping stress deep within the crust. Geologists call this isostatic rebound. This bedrock remembers a world without ice. The surface you started on does not. And this is what nations are positioning themselves to control. So why does any of this matter? Why are nations racing to build stations, run surveys, and establish a presence across Antarctica? Because beneath the ice lies value. Antarctica shares the same deep geology as South America, Africa, India, and Australia. Continents rich in coal, oil, metals, and rare elements. Geological surveys suggest vast resources buried beneath the ice, potentially worth trillions. For now, all of it is protected by the Antarctic Treaty, signed in 1959, which designates Antarctica as a zone for peace and science, prohibits military use, and suspends territorial claims. But in 2048, that ban can be reviewed. And that review could open the door to extraction. Some countries are already moving. Russia has carried out extensive seismic surveys and mapped potential oil and gas resources in Antarctic waters. China is rapidly expanding its Antarctic program, building new year-round stations and investing heavily in logistics, mapping, and polar research. Meanwhile, the United States Antarctic program is facing aging infrastructure, funding uncertainty, and growing pressure to prioritize elsewhere. The balance is shifting. The subglacial lakes, the hidden biosphere, the ancient rivers, the ecosystem powered by iron and nutrients flowing into the Southern Ocean. All of it exists in a fragile balance that took millions of years to create. "2048 is roughly 2 decades away. The race is already underway. 5 kilometers of ice cover a continent that stores ancient air, channels rivers through total darkness, and supports life without sunlight. Entire mountain ranges lie buried below the surface. The bedrock beneath Antarctica still records a time when this land was green. Antarctica is not empty, and it's not simple. It operates as a connected system that runs from bedrock to ice to ocean. Heat shapes the land. Ice controls the water. Water carries nutrients. Nutrients sustain life. Changes in one layer propagate through all the others. Systems like this take millions of years to form and far less time to disrupt. For over 60 years, the Antarctic Treaty has been held. In 2048, its protections can be reviewed. Countries positioning themselves as technology turns once unreachable places into viable targets. Some environments function precisely because they have been left alone. Antarctica is one of them.